Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Dagster offers a new approach to building and running data platforms and data pipelines. It is an open-source, cloud-native orchestrator for the whole development lifecycle, with integrated lineage and observability, a declarative programming model, and best-in-class testability. Your team can get up and running in minutes thanks to Dagster Cloud, an enterprise-class hosted solution that offers serverless and hybrid deployments, enhanced security, and on-demand ephemeral test deployments. Go to dataengineeringpodcast.com/Dagster today to get started, and your first 30 days are free. Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst powers petabyte-scale SQL analytics fast, at a fraction of the cost of traditional methods, so that you can meet all of your data needs, ranging from AI to data applications to complete analytics. Trusted by teams of all sizes, including Comcast and DoorDash, Starburst is a data lake analytics platform that delivers the adaptability and flexibility a Lakehouse ecosystem promises. And Starburst does all of this on an open architecture, with first-class support for Apache Iceberg, Delta Lake, and Hoodie, so you always maintain ownership of your data. Want to see Starburst in action? Go to dataengineeringpodcast.com/Starburst and get $500 in credits to try Starburst Galaxy today, the easiest and fastest way to get started using Trino. Your host is Tobias Macey, and today I'm interviewing Dain Sundstrom about building a data lakehouse with Trino and Iceberg. So, Dain, can you start by introducing yourself?
Well, I'm Dain Sundstrom. I am one of the founders of Trino and Presto before that. I am CTO at Starburst. I've been working in the data lake space for about 10 years now. Before that, I worked at some other startups, and before that, I was one of the original people at JBoss and spent a lot of time in Java EE and that sort of space.
And do you remember how you first got started working in data?
My background mostly was distributed computing. So out of college, I started working at United Healthcare on distributed computing using Intera DCE in the 90s, and then switched to like Java EE back when it was called something else. And as part of that, I wrote the object relational mapping tools for JBoss. Then eventually we long time forward started working at Facebook. And one of the original projects from the head of infrastructure was to come up with a faster, better way of interacting with their large data warehouse at the time. So this is like 10 years ago, and it was, 300-400 petabytes or something. It's dramatically bigger now. And they didn't have a team to do it. And myself and David Phillips and Martine have background in Java, extensive background, and databases and stuff like that. So we were available and we started working on it. But I'm mostly a distributed computing person. So I wrote most of the distributed computing parts of Trino, whereas like Martine's a deep language person. So he did a lot of the language optimizations, and David is deeply into databases, has been forever. And so built a lot of the database parts and the tooling and things like that.
As an outgrowth of that effort, along with a number of other contributions to the ecosystem, we have landed in this space where we have a new architectural paradigm for analytical systems that is largely phrased as the data lakehouse, as a midway point between data lakes and data warehouses. And for the purposes of this conversation, I'm wondering if you can give your definition of what constitutes a data lakehouse.
It's a really good question because I think people play fast and loose with it. So historically, I would say a data lake is you have traditional storage, external storage. So you're talking HDFS is generally what people are talking about it. But nowadays, HDFS is so rarely used. It's almost always some cloud object storage, S3, GCS, Azure stuff. So definitely all the data stored in that. And then I think the important part comes with a lakehouse of talking about standard data representations. So like you can be a vendor and store all your data in, S3 if it's proprietary stuff. And proprietary, I'm just going to define as you're the only one who really implements it. I don't care if you have an open spec or whatever, like it doesn't matter. Like if you're the only serious player in it, it's effectively proprietary. So where I think about it now, it's object storage It's doing it in the lake. So it isn't like, oh, I take the files and then I import them into my special proprietary format and then I process them and then I dump the data back out. That's the lake as a sidecar to you. So it's when you're doing transformations, when you're doing data maintenance, the data is operated on directly as the lake being your native form. Everything else is, a bolt-on, which not to say is terrible, it's just a different thing.
Absolutely. And another interesting aspect of the idea of the data lakehouse is that the reason for framing it as such is that it intends to add a lot of the user experience benefits that you get from a fully vertically integrated database system, such as data warehouses, whether that is an actual vertically integrated system, as of the days of yore, or a cloud native system where compute and storage are disaggregated but still presented as a single unified experience. And I'm wondering if you can talk to some of the ways that we have actually, as a community, hit that mark, and what are some of the areas where we're actually still falling short of the user experience presentation of this cohesive platform versus the parts where the gaps still show through and you can see that it's actually 5 different pieces that are trying to work together.
Yeah, I think we've done an okay job. I think we got a long ways to go, though. If you had asked me this question 3 years ago, I would have just gone on and on and on about the litany of like broken, weird tools that exist in the Lakehouse. I think things are starting to get better as people realize that this isn't like so much as like the community of users, it's the community of like the people implementing and maintaining the systems where like I think we've now started to figure out that like this paradox of choice is not a good thing. So before we had like Hive and there were 5 competing data formats and then that narrowed down to 2 and then everyone realized that what Hive was doing was really bad and not sustainable and having like you have 2 different tables next to each other and they're maintained in completely different ways and have different type systems and different schema evolution and so on. Like I can go on and on and on about the edges of it. So I think Iceberg came along and said, hey, we're just going to come up with a format for tables. It includes how tables move, how they're evolved, how they're managed, and covers a whole plethora of things, including like data types and how partitioning works and stats now and views and so on as a written down standard. Before it was just the Wild West, like literally like someone would check something into Hive and like invent an entire new system. Spark does this all the time. Like, okay, let's implement Spark bucketing V2, which is different than everything else. And if you want to know how it works, like go read the Spark code because some person just showed up and everyone's like, yeah, that's cool. So I think we've gotten a lot better on data in tables, the type system, that sort of thing is now fairly standardized and well understood. That said, Iceberg did it, and then immediately Databricks came along and dropped a competing product, which is kind of half finished. And so now I get to implement 2. And now there's more of these coming along and hoping that this time around we consolidate onto one very quickly because it's really kind of a mess. And you're basically, what happens is people like us in the Trino community, we have to implement all of these. And we only have so many people. So it's like we implement one really well and the rest suffer, or we implement all of them kind of okay. So it's difficult. Like right now, there are enough people. I think we're maintaining 3 of them. Hive Acid died, and that's like one of N tools. So like we can have the same conversation about security. We can have the same conversation about I don't know. There's like lots of these areas.
Absolutely. So I personally am actually using the Lakehouse architecture for my platform for sake of transparency. I am using Trino. I'm using the Starburst managed Galaxy. So get that out of the way. I'm using the Iceberg table format, which is largely transparent. I don't have to do a lot on the actual table format piece because Trino handles that piece of it for the most part. And so, as somebody who's using the Lakehouse paradigm, there are definitely a lot of niceties. I agree it's gotten a lot easier over the past couple of years than it was prior to that. A lot of the conversation seems to have cohered along a roughly standardized conception of what constitutes the Lakehouse. I do think that one of the areas that is still unfinished, or at least not as cohesive across the board, is that question of security and access control. That seems to be one of the areas where the overall data ecosystem it's not yet figured out. Everybody has their own thoughts on how it can and should be done. Everybody wants to own that experience. There aren't a lot of methods for being able to communicate roles and access across the layer boundaries. And I'm wondering if you can talk to some of the ways that that manifests in terms of that overall experience as a juxtaposition to the warehouse where everything is presented as one system.
Yeah. So, as one of the people who's written, I don't know, a huge portion of the security systems in Trino and in Galaxy, it's actually a really hard space to be in. So, like, if you kind of look into the open ecosystem, so like throughout this whole thing, we're kind of talking about the open ecosystem. So, the open ecosystem for security, historically, you had the Hive meta store with its security. Well, the most popular meta store out there is Glue, and it doesn't have the Hive security model. And the Hive security model was always weird and only applies to Hive. Trino's a federated system, so like that doesn't make much sense. Ranger pretty much died. I haven't seen it around in a while. Like there are people still kind of looking at it, but like I get a sense for how popular things are by like when people ask about things. And it's like 2 years ago, it just kind of fell off a cliff. And the only other thing I've seen out recently is OPA, which the Bloomberg folks have been working on, and they really like. OPA is really complicated. You write like security rule policies in a security rule server in a custom language. Like it is not, I literally looked at the language and I was like, if I did this, I would write a tool to write the language policy files for me. It's very complicated. So I think that's got a long ways to go. Hopefully someone builds like a UI and tooling and stuff for it. So that's really all you have in the open space. In proprietary, you have AWS's Lake Formation, which like I seriously have yet to meet someone who's rolled it out. It just looks weird. We'll see what happens. Again, I'm hoping it dies. Like every one of these things that's successful, we have to build and maintain. So like I'd like one, and I'd like it to be open. The Databricks has their own proprietary thing. At Starburst, we have our own proprietary thing. I think Tabular has their own proprietary thing. You end up with proprietary things because of the complexity of the security system. So like in Galaxy, we built the security system into the core of Galaxy itself. So Galaxy's the Starburst hosted version of Trino. So like every screen you're looking at in Galaxy is viewer aware, and we're applying your policy on like what you're allowed to see. And it's really core to the whole application. It kind of touches like every single bit. So how do you put that in? And then you're like, oh, I'm going to make this out call to a third party system. And like, I need to know it changes, but like, this is something I need to be able to do on like a millisecond level. And so security is a super hard problem. Also, everyone has different viewpoints about how security should work. In Galaxy, we followed a very traditional database security system with roles and access controls, etc. In other systems, like there's different viewpoints. Like it's very interesting. Like OPA is like this different universe of like policy rules systems. So I don't think we have a good answer for this right now in terms of like a community. And I think this is one of the things that actually is a reason why you would choose a vendor is their security implementation aligns with like what you want to do.
Yeah, the security and policy space is definitely still very much in flux, in particular in the Lakehouse ecosystem, but even beyond that. So OPA is a tool that came out of largely the Kubernetes ecosystem and is being applied to a number of different areas because it is a generalized policy language. There's another project called OSO, which is an open source policy engine that has its own policy language again, so that you can have the policy agent embedded in process in various language runtimes, and then you can define those policies out of band and apply them to the runtime dynamically. So I think that that is an interesting approach, and maybe something, whether it's OSO or OPA or one of the other tools in that ecosystem might start to make inroads into the data platform ecosystem as well. And then you also have things like identity systems like Keycloak or Okta or Auth0, et cetera, that also factor into all of that. So it's a big, complicated space.
I think part of the problem here is what are we optimizing for? So like OPA and Ranger, which is just another policy system, was great if you're an admin and you want to like lay down the rules like broadly for like lots of tables by using table matching. But like SQL security was really built around like I create a table, I type commands to grant access to other folks in the platform. I may create views or like, filter rules or something like that. And I'm just typing commands to do that in the SQL language. And that SQL language is the language of the system I'm in. So it's like that's a system that's optimized for end user experience, not admin experience. And the admin experience, it's great if you're a bank. OPA, like in Trino, came from Bloomberg, and it's like they have a lot of data and they have data policies they need to apply broadly. But if you're like a small group and you want to have a security system, like do you even have people that can write these complicated things? Can you run an OPA system that's going to return responses in milliseconds because it's part of like every query? No. And like really you want the system to be kind of in a simple, understandable way for end users. So it's like there's a lot of the stuff in data lakes are provided by big companies with big company solutions to big company problems. And it does not align with like, hey, I want to like grant access to this table to some other person.
Absolutely. And in the data lake and lakehouse ecosystem as well, there's the added complexity that by virtue of the storage and the compute being disaggregated, you maybe want to bring a different compute to that same storage. And so then there's the question of, okay, well, do I need to route all of my requests through the other compute engine that has my policy information? Do I have to have different policy sets and different rule sets across those different compute systems? So
it's actually worse than that too, because the outside of like Trino, the most popular compute engines are MapReduce like things like Spark and Hive. And the problem is that those engines almost always allow users to upload their own third-party code, untrusted third-party code into the same process. And that means that you can't rely on the process to be secure to protect against data access and stuff like that. So the Spark and Hive communities are pushing for things like column level encryption and physical security based on file permissions, which is like anathema to like the way SQL works. This would be the equivalent of like, oh, I'm going to manage my MySQL permissions by setting file permissions in the Unix file system. It's insane, right? And like this is like state of the art, and it's because like the entire industry went down this MapReduce path for 15 years, and it's not a good idea. Like you see like every single vendor who's working in the data space has moved away from MapReduce. Like, yeah, Spark still uses it, but like when you get into like high performance stuff, like everyone has moved away from MapReduce. It's just not a thing you do anymore. And we're still building our security systems to like the lowest common denominator.
And so, taking a step back now from ragging about the complexities of security, bringing it back around to Trino and Iceberg, I guess maybe keeping it in the context of security, what are the benefits that that particular pairing provides, and maybe in juxtaposition to other technology stacks or vendors that purport to provide a data lakehouse experience?
Today, I think the data warehouse, the folks talking about the data lake experience, and I'm using that in quotes, I think it kind of breaks down into two camps. You have folks who have a traditional data warehouse that can pretend like it's in the data lake. That's almost always done by you run a query, it loads the data into Snowflake format. They run their query and then they throw the data away or they cache it or something like that. But they don't actually execute directly on the Lakehouse data. So that's like one camp. And then the other camp would be obviously you have Iceberg camp, and then you have like the Delta Lake camp, which is similar. I have my bias. My bias is absolutely towards Iceberg. I was pretty unhappy when Delta Lake actually came out. It's unfortunate that like I thought we had this brief moment where it looked like the entire ecosystem was going to move onto Iceberg, and we would only have one thing to implement, not like five. and then Databricks dropped their format. And in my experience, the only people using it are Databricks customers, but they have a lot of customers. And so like everyone is having to implement it because Databricks made it the default format for their customers. When honestly, like their customers would be just as happy with Iceberg. So now we all get to build twice. And yeah, it's got a community, but like it's not the same thing as it being an Apache community. But even then, if there were two Apache projects, I'd be annoyed also. And then there's other groups that are trying to build stuff. So Trino and Iceberg, I think we're combining together, like, in my opinion, the best analytics and query engine we have available, along with the current best storage format. So without like Iceberg without Trino is like great. I have storage format, but like how do I query it? How do I interact and change and produce these files? Like, it's nice, but like it's not you're still suffering the problems of some of the other engines. And Trino, on the other hand, provides this great query engine that's adaptable. Like Trino has the ability to add in custom data types. We have direct readers for everything. So we can actually build an engine that's really, really tightly set up for what Iceberg can do. And we can do that in a way where you get really, really great performance. So what Trino was suffering from until Iceberg came along was the data formats weren't particularly good. And so like you would have performance problems, you would be missing stats. There's this really, most of the data formats and the way Hive was actually designed for HDFS, which has a very specific performance profile that S3 does not have. Like listing files is great in HDFS, is insanely slow in S3, and Iceberg doesn't require listing files. Like there's a whole bunch of things like that where Iceberg was designed to deal with the performance characteristics of object storage as opposed to like HDFS's design that, hardly anyone uses HDFS anymore. So like Iceberg gave us a really stable format with a well-run community that likes specs, that understands like the performance of modern things. And we were able to work really closely with them and build a query engine that's really tuned. The integration we're doing to Iceberg is fundamentally designed for Iceberg. It isn't like a bolt-on. It's like we took Hive and like swapped out a little bit. So like we wrote a custom plugin just for Iceberg that does exactly what Iceberg wants.
Are you sick and tired of salesy data conferences? The ones run by large tech companies and cloud vendors? Well, so am I. And that's why I started Data Council, the best vendor-neutral, no BS data conference around. I'm Pete Soderling, and I'd like to personally invite you to Austin this March 26th to 28th, where I'll play host to hundreds of attendees, 100 plus top speakers, and dozens of hot startups on the cutting edge of data science, engineering, and AI. The community that attends Data Council are some of the smartest founders, data scientists, lead engineers, CTOs, heads of data, investors, and community organizers who are all working together to build the future of data and AI. And as a listener to the Data Engineering Podcast, you can join us. Get a special discount off tickets by using the promo code DEPOD20. That's DEPOD20. I guarantee that you'll be inspired by the folks at the event, and I can't wait to see you there.
And when somebody is building a data platform or building their warehouse implementation, they decide, okay, this combination of Trino and Iceberg does what I want. I have the benefits of a performant query engine. I have the flexibility and scalability of object storage. I can scale those two things independently. How does that influence the other upstream and downstream choices that they might make for the other components of their data platform?
So once you decide you're going to go with Iceberg and Trino, you have the complexities of like, how do I actually get my data into these platforms? The bootstrap problem is a really big problem in data warehousing in general. It's like, how do I get my data in? In general, since Iceberg has become so popular that a lot of tools are adopting it, so actually getting your data in is less of a problem, but you definitely want to go and look at the vendors you're going to use for landing the data into your S3 bucket and make sure they support Parquet at the very least and Iceberg, hopefully. And if they're not supporting it, when are they going to support it? Because most of them have it on their roadmap, unless they're Databricks. Like even Databricks is starting to Iceberg support. So making sure your vendors actually are supporting landing data in Iceberg format. Then in terms of like other choices, you obviously have things like how is security going to work? How is data maintenance going to work? So Iceberg tables require maintenance on them. And depending on how you're importing data, they may require compaction, and you want to keep only so much snapshot data because they have the ability to query historic data, but that means you're holding historic data, which could be expensive. So there's a bunch of like maintenance things, and you're going to have to choose a tool that supports the maintenance. So many of the platforms like Starburst, we're integrating all of this stuff into our platform because we want to create the simplest experience for people. Like we don't want them to have to go and like integrate with a third-party tool to like run some compaction jobs. Then I think there's additional things around like you're going to use probably some sort of data transformation guiding pipeline like tool. It's almost always dbt. I don't even know if they have competitors, honestly. Yeah. And then obviously you're going to want some sort of BI tools. Most of them are supporting Trino or Starburst or both today. So there isn't much of a choice reduction there. But I think the big thing is like data ingest, getting it into Iceberg and maintaining those files are currently a big part of the platforms.
Absolutely. And I started my data lakehouse journey, I think maybe going on 2 years ago now. And in that 2 years, it has gotten better. Initially, there wasn't really any out-of-the-box support for being able to write into a lakehouse. You could write data into S3, but then you would have to perform a different step to actually tell whatever metastore you were using, hey, these files exist, this is the schema, these are the tables, etc. So my team is actually using Airbyte, and so we actually had to write a custom output plugin that sat on top of their S3 plugin to be able to automate generation of those AWS Glue tables for the data that was just written out, rather than having it be an out-of-band process of, oh, hey, I wrote all this data to S3, now I've got to wait for the crawler to run to tell me what those tables are, and it's probably going to be wrong anyway, etc.
Absolutely. I Airbyte, actually all of them, they either have it. If they do, it's not always the best, but like every single one of those vendors, I think, is realized that Iceberg is an important part of the data lake future, and they just need to be able to ingest directly into Iceberg.
And Airbyte does have that out of the box now. There are a couple of implementations. The level of support is not quite where I would like it to be. And then going back to one of your earlier comments as well, as far as the data type specifications being a bit all over the place, one of the things that is my personal pet peeve, at least in the Airbyte toolchain, I don't know if it exists elsewhere, but anything that has a decimal value is automatically a float, which if anybody knows anything about data types, that is an awful choice.
Yes, that is an absolutely awful choice. Funny enough, the first versions of Trino, we didn't have decimal. We only had doubles. And the actual migration away from them was quite an undertaking. We had like backwards compatible flags for a long while where you could be like, oh, if you see a literal, it's actually a double, not a decimal like it should have been in the spec.
So the version of the plugin that my team uses, we actually implemented the logic that says if it is a numeric type that has a decimal place, treat it as a decimal value, not as a float.
Yeah.
And so for people who are looking at the data lakehouse ecosystem, going from where we are today and looking into the near to medium term forward, what are some of the areas of progress that you see as far as overall improvement in the capabilities and user experience for the tooling that's available?
So I think we are finally at the point as of, this year that the rest of the vendor space has realized that Iceberg is a critical component. And they aren't even just starting. They figured this out like 6 months ago. Their products are starting to land. And that's a big change. Whereas like before, as you said, like, the history of like the data lake is you end up having to build a bunch of this stuff yourselves while the vendors figure out what's important. So there's a bunch of interesting parts to this. So there's like obviously things like landing data and data maintenance. It's going to be interesting to see how this shakes out in the next like year or two, as what happened before is happening again. Everyone realizes it's important, so everyone's going to build products around this. So now we're going to have competing products that all have slightly different features, which is a good thing, but it's also like a bad thing because it's the paradox of choice for the end users. You're going to have a lot of stuff to look at, and you have to consider like the data lake is about how things integrate together. So it's like, if I choose this product from this vendor, how does that work with my other products that I might be interested in from other vendors? Can I use Airbyte to land my data and then use a separate data maintenance tool that plays well with that landed data? And it's going to be a interesting next set of things around, like, now that we're moving on to Iceberg and we have Trino. So it's like, how do we get these different products to play well with it? And everyone's got kind of a different viewpoint on that.
And as a vendor supporting Trino, building a product powered by Trino, what are some of the areas of investment that you see as being most critical to easing that adoption curve, improving the effectiveness and user experience for people who are using Starburst specifically and Trino indirectly to just make their lives easier and help them get their jobs done?
Well, I should have mentioned this earlier. The most challenging thing that people have is actually like how they query their data. So we set up Trino, and the first thing you see in Starburst is a way of actually entering queries right in our UI and being able to run some queries. And then you're like, great, I want to put this in my BI tool. Like, how do I get this to my BI tool? So like that is a big area we actually think about, is like, how do we empower users to get this into the tools they want to use? Then the other part is kind of like generally like the admin part. How do I manage my security? We spend a lot of time around that. And I think the big areas that we look for are, how do we make it easier and easier for people to like set up their data lake? So one of the first things we focused on in the Galaxy development was, I call it time to first query. So you sign up, you can be running queries on your data warehouse in a minute, couple minutes. That's great. How do you get your data in? So we spent a bunch of time around data discovery, integrations, etc. And we're continuing to do more and more work around how you actually build up your initial lake and get your data into your lake. So I still think that's one of the big problems. So is this, how do you get data in, and just kind of focusing a lot of the data lake stuff. It's geeky stuff. It's like stuff I love, but it's like really detailed, and there's a lot of choice in the space. And really what I want as a non-technical end user, or even honestly my other friends that are insanely technical, they're like, that's great, but like, I don't want to learn how the low-level file system stuff works. Just like, I want to run some queries. So we spent a lot of time of just like, let's get it all working. And then if you want to like integrate with some additional stuff, because like that's important to you, like we can talk about how we do that. But really it's like, get up, get queries going, get excited about the Trino and what we're doing. And then we can talk about like, sometimes people are very opinionated about like, they want a certain specific integration the way they want to do it. But it's pretty rare. We hear it because we're in the community. But like outside of like data heads, people don't know what Ranger is or Parquet, or like, they don't know what any of this is. They're like, I just want to run some queries.
Yeah, as somebody who's been running this podcast for, I guess, 7 years now, whenever I talk to somebody who isn't deeply embedded in this space, I'm always struck by the fact that the things that I'm talking about, they have no clue and they don't care. And I'm like, wait a minute. All right, reset. I've got to remember that I'm talking to somebody who doesn't do this every day.
Yeah, I often find myself saying outside of data space, like, so in Excel, when you do X, we kind of do that, but the table's infinite. Like,
yeah, right. And going back to that question of landing data and the transformation, as you mentioned, most people these days are using dbt. There are some competitors, but not a lot of them and not on the same scale. But one of the benefits that Trino provides is, as you mentioned, it's a federated query engine. So rather than being constrained to, oh, I can only work on the data that's in my Iceberg tables, you can say, oh, I actually just want to directly query against my Postgres or my MySQL database or some of the other numerous data connectors that are out there. And I'm wondering what you see as the general pattern of people who are adopting Trino, whether they are still using the Airbyte or Fivetran as the only means of landing data into their Lakehouse, or if they're largely using that federated query capability to be able to do more kind of real-time data updates of from source systems into their Lakehouse via those transformation routes.
Very, very interesting question. So you're going to get the database answer, which is it depends. So it's interesting. So like federation is awesome. You typically you're not keeping your main data. Well, actually, let me back up. So normally when we're talking about federation, so like Trino in its heart is a federated query engine. That is like, we don't own the data. We're interacting with data and the descriptions of the tables that are all external. That said, the connectors that read data from like Object Store and Glue and that sort of thing, those are effectively native formats to Trino. Like we implement all the raw file reading logic. We talk directly to Glue. We're not talking to like another query engine. Whereas when we talk to MySQL, we send a query in MySQL's language to MySQL. So normally when we're talking about federation, we're talking about the stuff that's not the normal data lake queries. Folks that are, a lot of companies and users, et cetera, will have what I'll call dimensional data sitting in a production store that's like a MySQL or a Postgres. This could be as simple as like demographics for users, et cetera. So like they'll have their main feed of data, say it's an ads feed. And it's like, okay, user so-and-so saw this ad. You join in with their demographics, and then you can do analytics of like, the amount of ad clicks by age range or something like that. And you don't have age range in your normal ad feed. So that's really powerful. And it's easy to do because like you just connect them together. You don't have to set anything up. The downside is you're now accessing a production data store that like keeps your website running from your query engine. That can be fine if you're using like MySQL and you have a bunch of read replicas for your database. But that can also be expensive because a transaction processing database is more expensive to run than an analytics database for the amount of data. So sometimes you'll want to instead copy that data into your data warehouse. The other reason that you want to copy data in is you sometimes want historic data. So you need the demographics for that user when they saw the ad, especially when you're doing stuff where there's money involved and people are paying for certain ad impressions, or, you're doing, product stuff. You're selling things and like you want to record the state of the system at that point. So a lot of times then you'll be either dumping in data daily, or you can, with a lot of work, try and set up something like Debezium and get a feed into a data warehouse. It's very complicated today. So a lot of times you'll want to mirror the data in because you actually want a non-moving snapshot, because you want a non-moving snapshot or you want to reduce the pressure. So a lot of people start with the live and then move to the other one when they realize the cost or the pressure on their database. Moving can be really, really complicated though. Like the tools there are not good. The state of the art, the best tools are very challenging to use.
Absolutely. Digging a little bit deeper in there, I'm wondering if there are any other differences that you see in terms of the overall pipeline design, access, and usage patterns that folks are building around their usage of Trino and Iceberg as compared to maybe a warehouse or some of the other Lakehouse compositions that you've seen.
So there's the data warehousing space, I think in general, is kind of developing two different directions, especially in the open data lakes. So there's a large swath of people that are using something like DBT to do step-by-step transformations. There is a movement towards materialized views, which you just say, I want a materialization of this query, and here's the policy for keeping that up to date. A lot of people think they're equivalent. They are not. So materialized views are about when you're querying that, it's supposed to be the equivalent as if you just ran the underlying query. And so the data changes. Whereas like pipeline data has the advantage and disadvantage that like typically like you're processing on like, I don't know, let's say a daily or an hourly basis. If like the query changes or something like that changes in the pipeline, it's only future data that's affected, which is good and bad depending on what you're trying to accomplish. So like, I think that's an important split that's happening in the open community. And I'm curious to see which one's going to win. In terms of like open data lakes versus like proprietary ones, the biggest difference is that people don't keep all their data in their proprietary data lakes. It's just too expensive, or it's too complicated to move it all in. Whereas like normally people are storing all their data in S3, whether it's a data lake or not, because it's cheap and they can have a backup. But you don't keep all your data in Snowflake because it's either too expensive or it's too much of a burden to keep all the feeds to load it into their format. You see the same thing with Redshift and basically everything else out there. It's like, even if it were free, it's still just annoying.
And then another consideration that folks have when they're deciding whether or not they want to use a Lakehouse approach is sometimes they have queries that need to be able to operate very quickly. And so that's where they'll typically bring in something like a ClickHouse or a Druid when they're dealing with, fast moving data that needs to be updated quickly. And I'm wondering what you see as some of the decision points around going wholesale into one of those systems or using those as a supplement to a Trino and Iceberg setup.
Yeah, so my experience with those systems is that they're limited in their capabilities. So they're almost always used with a custom application, especially in the case of like Druid, where it's not standard SQL at all. It's very powerful, but your application is custom written to it. So you're not typically using it for general analytics. And if you're in that space, like you end up having a lot of choices of different things you can do. So in terms of like fast moving data, I think the open data lake is getting better at this very fast. I think that's a thing everyone's focusing on. So with Iceberg, you now have the Iceberg appending stuff that came in, 2 years ago, 3 years ago? Like you see more and more of people using tools to take data off of event streams like Kafka and landing it into tables at high resolution and then having background compaction jobs to deal with the insane number of files you create. And then downstream of that, there are a bunch of vendors and open source projects working on taking okay, so now we have this new data. How do we integrate that into the computations? I would guess within a couple of years, you're going to see everyone building something around this. It'll be like everything else. A lot of them will be bad, but I think the overall community is going to be more and more of bringing in data at near real time and being able to have it manipulated in a near real time feed. That said, that is near real time. Getting down to milliseconds, anything under 30 seconds typically means you have a custom engine where as you're bringing the feeds in, they're going into main memory and they're being held in memory because you can't even get them to distributed disk. It's not fast enough. Those, I think, will continue to be fairly proprietary systems. They're kind of complicated to write. So that's where you'll see the few vendors in that space. My experience is that most people don't need anything short of a minute. It's very rare to see that. The reason you see Hoodie came out of Uber is because they were using their real-time system to adjust pricing on the fly. Well, how many organizations have that problem? None. That outside of delivery services, those are the only people I know who use those systems.
Absolutely. And As somebody who has been working in this space for a number of years, as somebody who is building and investing in the Lakehouse architecture paradigm, you're very deeply entrenched in that ecosystem. What are some of the most interesting or innovative or unexpected ways that you have seen Trino Lakehouses applied?
So the most interesting cases almost always are custom applications. I've seen so many like standard warehouse stuff that like they all kind of blend together and be less interesting. Where it becomes really interesting is when someone builds a custom application, especially in Trino if they're building a custom data store to match. So you have things like companies that run big like CDNs and stuff like that, building a custom data store that hooks directly into their CDN and can like show the live data feeds, and like security systems where you're hooked into the live security views or ad systems. Like we built a bunch of these at Facebook for like hooking into the live ad system, live A/B testing, where you have like a custom data store that's specifically tuned to a problem with like indexes that are for petabyte scale data. You can do really, really powerful things with Trino because of the way the query engine is extensible. You can add new types and functions and all sorts of stuff into it and end up with extremely responsive systems that do really custom things at big scale. That said, like you need a team of like high skilled engineers to build something like that, which is worthwhile if like this is your entire business. I think the more common interesting thing is like ingesting data and setting it up and getting a bunch of people running their queries, which is like pretty mundane, but it's like the power of like when you give your people access to data and their ability to make better decisions is just like it's just night and day.
And in your experience of building these systems, working with customers, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process of working in this data lakehouse ecosystem?
I think the most frustrating thing is you run into different requirement viewpoints on things. So it's like you think you understand like what people are interested in and you start building that, and then like someone comes along and they're like, no, I actually am very interested in the opposite direction. So we had a bunch of people that were interested in like, I don't care what the file formats are, I just want this stuff to go really fast. You have this advantage of your ability to move faster and build really custom things if you can change anything you want at any time. It's actually a huge advantage that the big proprietary vendors have. Well, once you get to scale, you can't really do that. But in the early days, it's very fun and you can move very fast. But at the same time, like in our space, the reality is like we are in this open data space. So it's like if I extend stuff and no one uses it, I'm no longer in that space. So it's often challenging to figure out like how do we thread the needle of like actually making things a lot better without stepping outside that bound. So like we're doing a lot of work around Iceberg and Iceberg maintenance, and we spent a lot of time thinking about like, hey, should we just be like in Starburst, should we be just pulling this into our separate space? And then like maybe we're not even using Iceberg manifest files. Maybe we're using something else in like a transactional database. And then I can do indexing in ways that are impossible right now. And we decided that no, we're the open data lake space, so it's like we got to figure out how to do it in the open formats. Sometimes it's like we have augmented data in special fields or sidecar files or that sort of thing to be able to like give us the additional information that we need to make our engine go faster. Sometimes like you get on Slack and you hit up Ryan Blue and you're like, yeah, how about we just add some stuff into the spec to be able to handle this? Like I'm sure everyone has this problem. So that's the like I want to move faster, but I can't move faster. That I want to. It drives me nuts when it's like I know there's a better solution, and it's like I can't do it without breaking and making the thing proprietary. And then even then I have to like wait for others to catch up.
Absolutely. For people who are in the process of designing their data systems or they're looking to build a new set of capabilities in their data platform, what are the cases where a lakehouse architecture is the wrong choice?
So I also would say a few years ago, this answer was a lot easier. I think nowadays the open data lakes are very good. Where I think it's helpful with some of the vertically integrated players is you don't have to understand a whole lot. You're just, again, you show up and you just use the tool. And I think that's where data lakes suffered. Like back to the original Cloudera stuff. And if you ever tried to install it, they had like 10,000 choices of different tools to install. And it's like, I just want to work with my data. So it's like their entire id was choice. And that was the worst part about their product. It was like too much choice. I think we've done a great job at Starburst around like simplifying getting started on your lake and getting going in your lake. You also had this problem in the past where I would say that there's a lot of people who feel like they need to use a lake because they heard it, or a data warehouse in general, and they don't actually have a data warehousing problem. Like they could just use Postgres and don't have a lot of data. Also, we see a lot of people that want to do federation and they don't understand like federation is like we just send queries to the other system and they're like, well, it'll make my stuff faster. And so I don't think we've done a great job of describing when you would choose to even move to a data warehouse. And then in terms of like proprietary versus non, it's a tough choice. They can get you self going, but they can be very expensive, complex to manage, and you're bolted into that thing. Like, I don't know if you've ever seen someone tried to move from a traditional warehouse to an open one. It's not super easy. I don't want to say it's hard. Like, we do a lot of business of moving people off the lakes, but it would have been a lot easier if they had started on the lake.
Absolutely. And as you continue to build and iterate on the Trino platform and the Starburst product, what are some of the things you have planned for the near to medium term, or any particular projects or problem areas you're excited to explore?
So on the open source side, there's a bunch of stuff I'm very interested in around how we can spin people up on Trino in a faster and easier way. So we're doing more around simplifying the setups, simplifying the installation process, making it work in smaller environments, things like that. Better integrations with the different ecosystems. Like I want to see much more work done with better integrations with the Python ecosystem in particular. So one of the big areas that I have been focusing on recently has been around how you actually set up Trino. So historically, Trino was designed and operated as you had a data lake with Hive in it and nowadays Spark in it, and you're adding Trino because both of those query engines are really slow and not particularly good to use. Now we're at the point where a lot of people just run it and they don't have Hive and Spark. So there were things we would assume would already exist because you had those other tools. And so like now we're going back and adding a bunch of like things where normally you would have just fired up the Hive console and run some commands, and like you just don't have that anymore. So another big area is you set up Trino and it's like, oh, you want to set up a new catalog. And in the old days, you knew what you wanted to connect to because you already had a data lake. And so you just create this little catalog file and modify it and just restart your server until things work. Well, that's just not how people do it anymore. Now they fire up the Trino and it's like, okay, I want to connect to my S3. And it's like, to go edit a file, why can't I run a SQL command? So recently added a bunch of stuff around create catalog, drop catalog. There's still more to be done, like alter catalog. Right now, it's still just under the covers modifying like local files, but we have some work on like putting it into a real database. So it's funny. It's like you think about this and it's like in the Trino ecosystem and it's like, what do you mean you're not storing your catalogs in like a normal catalog system? It's like, we never needed to. And it's like at Starburst, like with Galaxy, we've had this from the beginning. You go into the UI, you just modify your catalogs and like everything's kind of live-ish. It's getting even more live with these changes we're putting in Trino. So like you will be able to just add catalogs or remove them a lot easier and maintain your system, put in a bunch more stuff around like data evolution and things like that. So I'm excited about this. Like, how do we bring more people into this community? Because I think we're very much at the point where the difference between what I can do in a traditional data warehouse and what I can do in Trino is a much, much smaller gap. Like when we started Trino, we're like, we're going to be able to take out traditional data warehouses with this. Like we're going to build something that's as good as that. We're 10 years in, and I think for the vast majority of cases, like we've been able to take them out for years and years and years. But it's like this new user case, I think, is like the one remaining spot. And like when we started this project, we said it's going to take 10 years. I think we're there. Like just need to like just a little bit more, and I think we will have covered pretty much everything all the way down to like a new user with like a couple of files they want to process.
It's funny how persistent that 10-year time horizon is. Pretty much every time I talk to somebody who has built or is building a database engine, they always say it takes 10 years before you get it right.
Yeah. The other thing they don't say is like, it kind of takes 5 years before, kind of doesn't suck, It was pretty good, but like, people like, we didn't have the ability to write tables for the first year. Like, whatever, we got data, we got Hive, it's writing data for us. We'll just run queries, right, that select the data out. So it's like the amount of stuff from like, oh, this is actually interesting and kind of works, to like, I can use it everywhere, is like, people have no idea.
Absolutely. It's amazing how many products have been built because the person building it didn't realize how hard it was going to be.
Yeah. I honestly, I think that's almost every project I work on. Is like, If I knew, I probably would start.
And are there any other aspects of the work that you're doing on Trino and this overall space of the Data Lakehouse ecosystem, the combination of Trino and Iceberg that we didn't discuss yet, that you'd like to cover before we close out the show?
I think we actually covered all of it.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I really, really think we need a big improvement in the security space. And I don't really care what it is, other than like it needs to work well with things like Trino and the maintenance. Like the amount of complexity you have to go through to set those policies, you have to learn a new language. That's way too complicated. And frankly, it's, even if you do learn the language, you're going to get the policies wrong because you're no expert in it. So they're too complex of models. The other space is, I still think it's too hard to get data into the lakes. It just needs to work and land and be maintained. And like, you shouldn't have to think about it. It should always work and be low cost, and data just shows up. Like, why do I have to worry about, all the feeds?
All right. Well, thank you very much for taking the time today to join me and share the work that you and your team have been doing on bringing the Data Lakehouse ecosystem into a better place, and all the work that you're doing to build the Starburst product definitely makes the onboarding a lot easier for folks. So definitely like the work that you and your team are doing there. So thanks again for taking the time, and I hope you enjoy the rest of your day.
Thank you. This was great.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.